Dungeness, Britain's wild east. Paul and Andy are on one of the biggest, longest, most expensive and most difficult clean-up jobs in the world. They have to get rid of this, the Dungeness A nuclear power station. The job? Remove over 500 tons of spent fuel in 54,000 fuel rods. The problem? It's radioactive. Handling could give you radiation sickness. If it isn't kept underwater, it will overheat or even catch fire. This is the world's most frightening grime, and it'll stay that way for decades. Job 1. Get the fuel rods out of the reactor.
This is one of the actual fuel rods. Obviously this one's a dummy and is empty. There's 27,000 of these in each reactor. We have 2 reactors.
Fuel rod facts. Inside, 10 kilos of radioactive uranium. Job: to make heat, which makes steam, which makes electricity. Problem: after years in the reactor, spent fuel is hot, radioactive, and potentially toxic.
We need to remove those from the reactor core and eventually send them off to Sellafield.
If Andy and Paul seem relaxed about handling hot radioactive fuel rods, that's because they don't plan to get very close to them. But if they are exposed to radiation, they need to know about it.
Right, this is an electronic personal dose meter, and it just measures what radiation dose we get.
There is a possibility you might pick up a bit of contamination.
Contamination could be radioactive dust. If it's there, the boots and suits make sure it never gets out.
The barrier marks the contamination controlled area, which is, we class it as the dirty side. So we're ready to go into the dirty side now.
Well, we've all crossed over to the dirty side at one time or another. For Andy and Paul, the serious part of their day is about to begin. They're going to open up the reactor. When it shut down in 2006, Dungeness A was Britain's longest-running nuclear power station. Andy and Paul are about to open up the reactor and remove the highly radioactive uranium fuel.
Okay, so what we're doing now is we're lifting up a slab, and it's 2 foot thick concrete, and that really, it's our kind of last bit of shielding before we get to the reactor.
Under their feet is the steel reactor vessel, containing 200 tons of uranium. Today, Andy's drawn the short straw and gets to stand on top of a nuclear reactor.
This is the standpipe assembly. This is where we actually go in to actually pull out the irradiated fuel.
Of course, they're not literally going to go in and pull out the fuel. The fuel is handled by the charge machine, a robot crane that will pull out the rod and then drop it down a chute into the storage pond. Storage pond facts. Job: to cool fuel rods and shield operators from radiation. In the tsunami-hit Fukushima reactors in Japan, the big fear was ponds boiling dry and fuel rods catching fire, melting or exploding.
Yeah, it was about 10 years ago when I first came down here, and it was a bit unnerving at first. There's very little dose down here now, so actually there's quite a nice breeze down here, so it's quite cool.
When the reactor was running before 2006, it was anything but cool.
Before, it used to be, if you had to go up to the top of the charge machine, you're in the 40s. That's how warm it was when it was running.
Andy's preparing the reactor to receive the charge machine.
Okay, down you go.
They've done this thousands of times, and every time it's slow and careful. But steady on, something's about to happen.
This is the exciting bit now, because the charge machine, which we're going to bring over, put on top, is actually going to become part of the reactor. Once that's part of the reactor, then we can start to pull out the irradiated fuel.
The spent rods have been inside the heavily shielded reactor vessel. They're about to come out. Back at Dungeness, the huge job of decommissioning the nuclear power station has reached a critical point. Andy and Paul are about to lift spent fuel from the core of the reactor. Packaged inside metal rods, the fuel is radioactive and toxic and has to be handled with care. A remote control grab lifts fuel rods from inside the reactor. Andy checks all's well by video link.
So we're now coming up to the viewing zone, and here we've got the jaws that are attached, and this is the first time we see the actual fuel element, and this is part of the spider, and you can see the actual fins now of the fuel element.
Then they drop down chutes into the storage ponds. 20 foot of water keeps the rods cool and shields the workers. Spent fuel rods are more radioactive than fresh ones. From now on, all operations are underwater.
As we're now discharging the fuel down, and everything is recorded.
Next job, move the rod to a storage skip. The fuel's going to leave the building in flasks, but they're not the sort you'd use to keep your tea warm. Each flask weighs 50 tons, made of 14-inch thick steel. It's watertight, airtight, and it's been designed to survive an 80-mile-an-hour train crash. And to prove it, in 1984, they did just that. Crashed a train at over 80 miles an hour into a nuclear flask laying on the track, with its most vulnerable parts exposed. The flask survived without spilling its contents. The train didn't. The flask takes a shower. By soaking the paint with clean water, it won't absorb contaminated water from the pond.
We're lowering the flask down into the flask loading bay. Then he'll take the flask right down to the bottom of the ponds. It's slightly caustic. I mean, you wouldn't want to go swimming in it, that's for sure.
You wouldn't want to go swimming because A, at the bottom of the pond are a load of radioactive fuel rods, and B, the water is caustic to stop the fuel rods corroding. If that happens, radioactive sludge would form and build up on the bottom of the pond. And that's hard to get rid of. The Dungeness ponds are very clean, but that doesn't mean they're completely safe.
Obviously the water's contaminated and there is a certain amount of radiation coming off from the ponds, but it's still well within safety limits.
Finally, Paul lifts a skip of used fuel rods into the flask.
Everything's got a number, so we know where everything is, and that's the most important thing. That's perfect, right in the middle.
This is another 166 elements. We've got rid of 27,000 so far, and so 27,000 to go.
Safely behind 14 inches of steel, the rods are about to make a journey. A 400-mile cross-country trip by truck and train. At Dungeness, the 50-ton flask of radioactive fuel rods is filled, sealed and tested. It's about to take a truck and train ride nearly 400 miles for reprocessing and storage. Here comes the transport. In charge of the truck are sisters Rebecca and Sarah Coleman.
Today I'm the shotgun. Rebecca here's the driver. And it's basically just our responsibility to get the flask from site to the railhead and back again.
You concentrate as much as you can with any load and you just get on with it. And
I don't give it a second thought really. I mean, it's no different to driving my car really.
Which means she must drive her car very slowly and carefully. It'd be embarrassing if something as simple as a flat tyre stopped the nuclear truck.
just checking our air valves, tanks, making sure there's no gunk or anything in there.
Right, this is the final check before it goes out. It's a reassurance monitoring check. I'm just rubbing over pretty much all the accessible areas of the flask I can get to.
And that basically is a 100% tacky swab checks.
A tacky swab is a sticky cloth that picks up any contaminated particles on the outside of the flask.
As long as that comes up as a clean check, that's his lot then, and that's our last check.
This one's clean and good to go. It's just a short drive to the private railway station. Then it's off to Sellafield, where some of the fuel will be reused. The waste will be placed deep underground. It could be there for thousands of years. When all the fuel's gone, the reactor will be sealed up for 50 years until it's safe enough for demolition to start. They'll remove the last brick in over 80 years' time. It's scheduled for the year 2098.